दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, I am R.N. Panda. I welcome all of you. Last class I talked to you what is valency and what is valency state and what is octet rule and concept of electronic theory of valency and how to get the valency from the periodic table. So we have defined the valency is the combining capacity of the atom of an element. The valency is a number, is the combining capacity of the atom of an element is equal to number of atoms of hydrogen can combine with one atom of the element. Being a number, valency does not have any sign, it will not be a fraction and does not have any unit. Now after the discovery of the structure of atom, the atom consists of electron, proton and neutron. When Rutherford confirmed the Rutherford model of atom, then the concept of atomic number came in. The atomic number is the fundamental property of the atom of an element, is an ordinal number which is equal to number of electrons, protons present in the atom. So taking this into two, again the concept of valency was proposed with respect to the electrons. The proton and neutron constitute the nucleus of atom. The electrons are moving in the orbits or the cells, and there are number of cells in the atom. And then proton and neutron, they constitute the nucleus. The electron is moving around the nucleus. Hence, it was confirmed it is the electron, the fundamental particle, which is responsible for the chemical combination of the atom of an element. Two atoms take part in chemical combination means the electrons of the two atoms, they take part in chemical combination. So this concept was confirmed, and taking this into account, the valency was again recast, valency was redefined. So I told you in my last class, the Kosel observed that the rare gas elements, helium, neon, argon, krypton, xenon, radon, all of them have 8 electrons in their outermost shell and do not take part in chemical combination even under extreme conditions, were named as inert gases. Since they attain chemical stability, and an atom after taking part in chemical combination do not again take part in chemical combination, it attains chemical stability. Hence Kosel confirmed that the atoms of every element have a strong tendency to attain octet in their outermost shell or the nearest inert gas structure. Hence the atoms take part in chemical combination. So the number of electrons, so during the chemical combination, the atoms of the combining element either they lose or gain the electron or contribute and share the electron to attain octet or the nearest inert gas structure. Hence this is called as rule of octet. So according to rule of octet, the definition of valency was restated as the valency of the atom of an element is equal to the number of electrons to be lost or to be gained or to be shared in the outermost shell of the atom of an element to take part to attain octet or nearest inert gas structure. If it is losing or gaining one electron, its valency is 1. If it is losing 2 electrons or gaining 2 electrons, its valency 2. If it is sharing 2 electrons, the valency 2. If it is sharing 4 electrons, then valency 4. Like this, the valency was recasted, and this concept was known as electronic theory of valency, and this rule was known as octet rule. This I have taught to you in my last class. I am recapitulating what I have taught you. Now coming to this, my point is, we cannot remember the valency of the elements one by one because there are 118 elements. So if are now finding a systematic approach to find out the valency of the element in the periodic table. Last class I told you that the Manley proposed the periodic table in the year 1869. Then at that time nothing was known about the electron, proton, nothing was known at that time. Then the atomic structure, discovery of electron, proton, the atomic structure was started developing. Rutherford proposed the Rutherford model of atom in the year 1908. Then Bohr proposed the Bohr model of atom in 1913. In the year 1913, Moseley discovered that it is not the atomic mass, it is the atomic number, the fundamental property of the atom element. So the periodic law was modified and restated as modern periodic law. The physical and chemical properties of the elements are the periodic function of their atomic number. Or if the elements are arranged in the increasing order of their atomic number, then their physical and chemical properties will find a systematic regular change. So the Manley periodic table was recasted because more elements were discovered and the gaps which were there, they were filled up, and then periodic table came as the Manley periodic table was there first. Manley periodic table. Here the periodic table in the year 1869, where it was written according to atomic mass. Atomic mass was taken as the basis for classifying the elements. Then came the discovery of electron, proton, then came the discovery of atomic number by Moseley. Then the periodic table was recasted, and that was called as modern periodic table. And here it was in the year almost towards 1913, after the discovery of atomic number, and elements were arranged according to atomic number. Then again it was developed, the electron concept of orbitals came, sp, d, f orbitals. Then some electrons were found in s block, p orbital, d orbital and f orbital. So accordingly the elements were classified, and after that this modern periodic table was expanded, and that expanded form of modern periodic table is called as long form of periodic table. It is an expanded form of modern periodic table and long form of periodic table, they are same, but here it is both are same. There it is whole periodic table was divided into 4 blocks: S block, P block, D block, F block. And here here the elements are arranged according to atomic number, and groups were divided into A subgroup, B subgroup. So I am using this modern periodic table to explain you the valency, because here in the modern periodic table there are 9 groups in the periodic table. Then what is a group? I told you last class, the groups are the vertical columns. Groups are the vertical columns. Means when you have the vertical columns, and the group number indicates the number of electrons present in the outermost cell of the atom of an element. Please remember that I am talking to you modern periodic table. Don't confuse with long form periodic table. So here the group number indicates the number of electrons present in the outermost cell of the atom of an element, and the atom of elements having similar electron configuration were placed under same group of the periodic table. So in the group 1A, so in group 1A, I told last class, all the elements have one electron in their outermost cell. Their group 1A, hence their valency is 1. The valency is 1, or all these elements are monovalent. All these elements are monovalent. Who are they? Hydrogen, lithium, sodium, potassium, rubidium, and cesium. Cesium and francium. I told you this francium is a radioactive element. We don't consider so far the valence is concerned. Now coming to second A group. Here all the elements are having 2 electrons in their outermost cell, in their s orbital. So they have NS2 configuration. So the group number indicates the valency of the element. The group number indicates the valency of the element. So how many electrons are here? 2 electrons. So these elements, these group 2 elements, these elements, they will be divalent. Their valence is 2. They are divalent. Who are the elements? Beryllium, magnesium, calcium, strontium, barium, and radium. So this again, radium is a radioactive element. I'm making a circle that indicates all these elements are radioactive elements, and these elements, these group 1 elements, they are called as alkali metals. These elements are called as alkali. All these elements are metals except hydrogen. All are metals, and they are called as alkali metals, where their hydroxides are alkaline. And all these elements, beryllium, magnesium, calcium, strontium, barium, they occur in the earth. And their hydroxides are alkaline, and they have valency 2. They are called as alkaline. They are called as alkaline earth metals. They are called as alkaline earth metals. And all these elements are electropositive elements. All these elements are electropositive elements. They are electropositive elements, and they belong to S block of this, both group 1A and 2A. They belong to S block of the periodic table. They are placed in the extreme left of the periodic table. Look to the periodic table. I have given a periodic table on the screen last class. It is available in your screen, and or if you have a book, open the modern periodic table. Left 1A and 2A, they are called as S block elements, and all these elements are normal elements because they exhibit normal valency. Normal elements. So all the elements of group 1 will have valency 1. They will never have more than one valency state. All the elements belong to group 2 will have valency 2. Their valency 2. Children, look here. You are remembering calcium 2, barium 2, like this you are remembering. You are asked to remember. In your school, you are asked to remember. I told you, more you forget, more you remember. So that's the reason we have a way to find out the periodic table is our tinderbox. Anything you want in chemistry. I will be teaching you chemistry, all the chemical reactions, all the chemical reactivity, everything we will go from the periodic table. So you will have one thing, and this periodic table for a student of science or chemistry is all in one. We call it all in one. Everything is there in the periodic table. Valency you will know, type of element you will know, metals, non-metals, oxides, acidic oxides, basic oxides, chemical reactivity, everything, whatever you want regarding the chemistry of element, you can know from the periodic table. Now I'll come to the P block of the periodic table. You look to your periodic table, and what is the P block? In the right extreme side of the periodic table. In the right extreme side of the periodic table, there are 6 groups. look there. So last we have the 0 group. So you have the 3A, we have 3A, then 4A, then 5A, 6A, and 7A, and 0 group. 0 group. All these elements, and these, they are called in the P block of the periodic table. They are called the P block of the periodic table. So we'll have no elements. So here we'll have the first period, n is equal to 1. The first period, we don't have only one element, that is called helium. That is called helium, atomic number 2. It has a completed, its cell will not take part in chemical combination, and no other elements are there. Now if you come n is equal to 2, second period, so we have 3A, boron, carbon, silicon, phosphorus, boron, carbon, we have the boron, carbon, nitrogen, nitrogen, then oxygen, then fluorine, then neon. I told you now, the group number indicates the number of electrons present in the outermost cell. Which group? 3A. So they will have 3 electrons in their outermost cell. They will have 3 electrons in their outermost cell. Then if you come to this 4A, carbon, it will have 4 electrons in the outermost cell. And 5A, it will have 5 electrons in the outermost cell. And 6A, it will have 6 electrons in the outermost cell. And 7A, it will have the 7 electrons in their outermost cell. So now coming to third period of the periodic table, you will have aluminium. So boron is 5, carbon is 6, atomic number, nitrogen 7, oxygen is 8, fluorine is 9, neon is 10. Now if you come to aluminium, 13, and the silicon, 14, phosphorus, 15, sulfur, 16, chlorine, 17, and argon, 18. So here 18 electrons, so it will have 2, 8, 8, completely filled self configuration inert, and is 2, 8, and this is 2. So it will not take, so here 7 electrons, 6 electrons, 5 electrons, 4 electrons, 3 electrons. So then we'll come to the next period. We'll come n is equal to 4, gallium, atomic number 31, germanium, Ge, 32, then arsenic, As, 33, then selenium, 34, then bromine, 35, and krypton, 36. 6 electrons, so you have 2, 8, 18, 8. This I have taught you last class. Now coming to nitrogen is 5, fifth period. Fifth period, we'll have here indium, 41, 49, then tin, 50, then antimony, 51, tellurium, 52, iodine, 53, then xenon, 54, so 2, 8, 18, 18, 8. You see, now coming to the sixth period is the longer period of the periodic table, with thallium, then lead, these 82, these 81, then 83 is antimony, and 84 is polonium, and 85 is astatine, and radon 86. It is 2, 8, 18, 32, 18, 8. You see, atoms of all these elements, they have 8 electrons in their outermost cell, that is called octet. Octet. And this has completed so this is called duplet. So they have no tendency to react. So all these elements they are called zero valence. They are the zero valent. Hence they were called as zero group elements. Now children, you see now group 3A. How many electrons are here? 3 electrons. So they will exhibiting valency 3. Their valency will be how many? 3. If you carbon, silicon, germanium, tin, lead, they will have valency 4. If you come to nitrogen, phosphorus, this, they will have 5 electrons in their outermost cell. If I write the configuration, general configuration, if I write, cell number is N, so their configuration is NS2, NP1. Here their configuration is NS2, NP2. Here they are NS2, NP3, and is NS2, NP4, and you have NS2, NP5, and these NS2, NP6. So these are orbitals. So you see here how many electrons? 2 plus 1, 3 electrons. How many? 2 plus 2, 4 electrons. Group 4A, 4 electrons. So the group number indicates the maximum valency state. Last class, so this is the way. Now you can see the periodic table. So last class I told you, so there are 7 periods in the periodic table. You see, if you go to our week, a student once asked me, sir, discoveries are being made so fast, the elements are being discovered, sir, will there be 8th period in the periodic table? Yes, there will be 8th period in the periodic table, but the week will have 8 days, the periodic table will have 8 periods. How many days are there in the week? We have 7 days. And how nicely the science is related to the nature. So many often we say the science is nothing but a scripture of study of the nature. What is happening naturally, that is happening in the science, because all these elements are naturally occurring. They are naturally occurring elements. They have their nature. We are studying their nature. So if you come to there are 7 continents in the world. There are 7 continents in the world. There are 7 days in the week. There are 7 periods in the periodic table. How they are having similarity with different aspects. And at the age of 7, the Lord Krishna in the Gop raised his mountain in his little finger when Indra was raining thunders, and all the people were there under the mountain there. So all these are effect of number 7. So now group number indicates the number of electrons present in the outermost cell. So now if we come to group 3A elements, will have they have how many electrons? They have 3 electrons. 3 electrons. NS2, NP1. In s orbital they have 2 electrons. In p orbital they have 2 electrons. So they will be what? They are trivalent. All these elements are trivalent. Their valency will never be more than 3. They will never exhibit valency 1, valency 2. They will not exhibit. They will only exhibit valency 3. All these elements are, I can say that all these elements are normal elements. All these elements are normal elements. So you can very easily configure the valency. So who are the trivalent elements? They are boron, aluminium, gallium, indium, and thallium. All these elements, they will have valency 3. So you will not remember the valency of aluminium. Valency of indium is 3. You know they belong to group 3. So the valency is 3. Now we'll come to the group 4. I am rubbing it up because you must have written all these things. So now you come to group 4. Who are the elements? Carbon, silicon, germanium, tin, lead. How many group? What I told you, the group number indicates the number of electrons present in the outermost cell. Number of electrons present in the outermost cell is the group number. So what will be their valency? 4. Normal valency will be 4. So what is the definition I told you? The valency of the atom of an element is equal to group number or 8 minus group number. Because what is the rule of octet? The atoms of every element have a strong tendency to attain octet in their outermost cell, either by losing electron or gaining electron, or by contributing and sharing electron with the atom with which they undergo chemical combination. So the octet 8 minus group number indicates the number of electrons present in the outermost cell. So 8 minus group number will give us the valency, or group number will give us the valency. So the group number is the maximum valency, highest valency state, maximum valency state of the element. It will not be more than that. So all the elements of group 4, if you come to group 4 elements, they have how many electrons? 4 electrons in their outermost cell. And who are the elements? Carbon, silicon, germanium, tin, lead. So their valency will be equal to what? They are tetravalent. Their normal valency is tetravalent. They are tetravalent. So they can lose 4 electrons at an octet. They can gain 4 electrons also attain octet. They have the 2 options with them. The number of atoms they can lose or they can gain, because they have 4 electrons. To become 8, they can lose 4 electrons, become 8. Or to become 8, they can gain 4 electrons or attain 8. So when they lose, means you see, giving, they will give. And when they receive, the gain means they will receive. So here it is there, give, it will give like this, and it will receive. So give and receive. So always those who give, they are positive, those who receive, they are negative. So when they will receive and react, they will exhibit negative character, and when they will give and react, they attain octet, they will activate positive character. I will come to that positive character, negative character. So then they can, and one more thing, so all these elements, they will have valency 4, tetravalent. Carbon, so carbon, silicon, germanium, tin, lead, they will have 4 valencies. So their normal valency will be 4, 4, 4. But these 3 elements, who? The silicon, tin, germanium, tin and lead. Germanium, tin and lead, they also exhibit valency 2. They exhibit valency 2 because they got NS2 and P2. NS2 and P2. When you will read S orbital, P orbital, S orbital has capacity 2. S orbital has capacity 2 like this. And P orbital has capacity 3. So in P orbital it has 1 electron. In the S orbital they have 2 electrons. So this pair is called inner pair, and here you will have 2 electrons. So these 2 electrons, when they will take part in chemical combination, they will exhibit valency 2, 2, 2. When all the 4 electrons will take part in chemical combination, it will be 4. So this pair is called as inert pair. Inert pair is not always available, inert pair. So because of inert pair effect, because of inert pair effect, because of inert pair effect, these elements, they will exhibit valency 2, also exhibit group number 8, they will exhibit valency 4. Now, if you, another one more thing I can tell you, friends, this, if you come to group 4, it is a very peculiar group in the periodic table. It is 4 electron. It can have it has 4 electrons. So it can give 4 or take 4. So if you come to group 4, carbon, silicon, germanium, tin, lead, the carbon is a not purely non-metal. Is a purely non-metal. And silicon is a non-metal. And the germanium is a metalloid. Tin has more metallic metal and lead is metal. See, down the group in the periodic table, तमे स्कूल रे पढ़िछ जो माने ओडिया मीडियम स्कूल रो आसीछ तुमको स्कूल रे पढ़ाई थिबो पर्याय सरणी बोली पढ़ाई थिबो सेठी तब सार कही थिबे गोटे एलिमेंट रे जो ग्रुप रे जो एलिमेंट रहिबे सेमानकर प्रॉपर्टी गुडाक समान हुए आउ तांको धर्म गुडाक मौलिक धर्म तळको गले बढ़ी बढ़ी जाए बा कमी कमी जाए और मौलिक धर्म थिला कोन ना नॉन मेटल नॉन तापरे मेटल कमी गला प्योरली नॉन मेटल और मेटल कैरेक्टर नहीं किंतु टिन सिलिकॉन पाखे टिके मेटालिक लास्टर रहिबो किंतु प्योरली नॉन मेटल नाउ इफ यू कम टू मेटलॉइड किए ना इट विल एग्जिबिट मेटल कैरेक्टर एंड नॉन मेटल कैरेक्टर एंड नॉन मेटल कैरेक्टर and tin is more metal, less non-metal, and lead is a completely metal. And so this is the group 4. They will exhibit valency 4, and these elements they will have a valency 2 and also valency 4. This is not variable valency, children. Don't say they are variable valency. That is the more than one valency state. That is not the variable valency. That is called more than one valency state they exhibit. Now we are coming to group 5. In group 5, the number of electrons present are 5. Group number indicates the number of electrons present in the outermost cell of the atom of element. The group number indicates the number of electrons present in the outermost cell of the atom of element. 5 electrons. And the orbitals are s orbital and p orbital. S orbital 2 electrons, p orbital 5 electrons. Means s orbital 2 electrons are paired, and p orbital they will have 3 electrons like this. So it will now how many 5 electrons? So group 5A, who are the elements? They will have configuration NS2 and P3. So they will exhibit 2 trivalencies, that is they can be pentavalent because they have 5 electrons, and they have 3 electrons also, they can be trivalent. So they exhibit 2 valency states, they exhibit trivalency and pentavalency. This trivalency because of their inert pair effect, and pentavalent they have 5 electrons in their outermost cell. If you come to nitrogen, phosphorus, arsenic, antimony, bismuth, they will their valency is 3. All of them will exhibit valency 3. Why? 3 unpaired electrons are there. They can run out and take part in chemical combination. They will go. And after that, 2 electrons. How are they? 1 electron is positive this side, other is this side. They are paired. So you have to remove them, unpair them, then allow them to react. So it will take time. We want to use a higher valency state. So they can also exhibit 5 pentavalence state. 5, 5, 5, 5. They exhibit pentavalency. They exhibit 2 valencies. They can be valency 3. Their combining capacity can be also 5. Their combining capacity can be 5. Their combining capacity can be 3. So when they will be 3, they are called trivalent. When they are exhibiting 5, they are pentavalent. And if you come to this nitrogen 3, it will not have pentavalency, it will not exhibit. And you come to 3, 5, this. So this is the way we go by this. They can lose electron and gain electron. These elements can lose 5 electrons, take part chemical combination, and gain 3 electrons and take part in chemical combination. So all these are normal elements, so they exhibit normal valency states. Now I'll come to the next group, group 6A of the periodic table. The elements are here how many electrons? 6 electrons. They have how many electrons? Group number indicates the number of electrons present in the outermost cell. The elements present in a group exhibit similar physical and chemical properties. Their properties down the group systematically change, periodically change, systematically change. If they are increasing, they will go on increasing. If they are decreasing, they will go on decreasing. So here, if you come to their group 6A, they have 6 electrons in their outermost cell. They are in need of 2 electrons to attain octet, NS2 and NP4. They need 2 electrons to attain octet, so they can take 2 electrons, so they will exhibit normal valency 2, and they can give all the 6 electrons and take part in chemical combination. So if you come to, these exhibits, they exhibit divalent. All the elements are divalent, and they may exhibit valency state 6. They may also exhibit, because the highest valency state of an element is the group number. Group number is the highest valency state of the element. So now oxygen, you have oxygen, it only exhibits valency 2. It will not exhibit more than 2. And sulfur exhibits 2 and also 6. Now if you come to selenium, can exhibit 2 and 6, and tellurium will have 2 and 6. So this is the way they can exhibit. And these, if you come to this oxygen is a nonmetal, and sulfur is a nonmetal. Gandhaka jota boli ame kouche, selenium is a metal, and tellurium is a metal. And we have the polonium. Polonium is a radioactive element. This element is a radioactive element. They undergo constant disintegration. Spontaneous disintegration. So oxygen only exhibits valency 2. Combining capacity is 2. Then we will come to the 7th group of the periodic table. All these elements have how many electrons? 7 electrons in their outermost cell. So they have a strong tendency to gain electron. They have no tendency to lose electron. Because what is the valency? The number of electrons to be lost or to be gained from the outermost cell of the atom of an element to attain octet or nearest inert gas structure. These are the inert gas. And after 1 electron they will gain. So all these elements will have a strong tendency to take 1 electron. Hence they are highly electronegative elements. So group 7A elements, they have 7 electrons in their outermost cell, that is NS2, NP5. They have 1 electron. If they take, they become 8. So they have strong tendency to accept electron. Hence all these elements are highly electronegative elements. All these elements are highly electronegative elements. They have a strong tendency to exhibit negative valency state. So all these elements, they have valency 1, monovalent. They are monovalent. They are highly electronegative element. Because why? Now they can tendency to accept electron to attain octet. And all these elements are called as halogens. They are also called as halogens. Halogens is a jugma pada jota ame kochu, a compound word. Halos means salt. Gen means producing. The Greek word halos means salt, and gen means producing, salt producing. They easily produce salts, hence they are called halogens, and they exhibit only valency 1. Also they can exhibit their valency state. They can exhibit valency 7. Now all these fluorine, if you come to their property, here fluorine is a gas, chlorine is a gas, bromine is a liquid, and iodine is a solid. Is a volatile solid. This is a volatile solid. The iodine is a volatile solid. Volatile solid. It is a liquid. This can go, bromine can become liquid and gas, iodine become solid, but chlorine is a gas and fluorine is a gas, and fluorine is the most electronegative element. If somebody puts a question, most electronegative element, and it is the highest, it has the highest electronegativity. It has the highest electronegativity. The highest electronegativity. All these elements, they exhibit, they take electron and this. So, and all these elements of group 0 group, their valency is 0. They have 8 electrons in their outermost shell, do not take part in chemical combination, hence very rightly their name is given them a 0 group. So this, see why since they are called 0 group, now we can relate the valency. Now you see how easily you could know the valency of all S block elements and all P block elements. You have nothing to remember, only then not some, very easily you can see. And the atomic numbers I am writing 9, 17, 35, 53, 85. I will, after this teaching valency, you will not remember the atomic numbers also. I will tell you how you can write the atomic number of element. Only thing, you make a attempt. You have 7 periods, so you take 7 periods. The first period 2 elements, second period there are 8 elements, third period there are 8 elements, fourth period there are 18 elements, fifth period 18 elements, sixth period 32 elements, seventh period 32 elements. So you have the like this, the period, incomplete period, seventh period is the incomplete period, sixth period is the longest period, 32 elements, fifth period is a longer period, and the fourth period has 18 elements. So by this, every day you try to write one period and write the symbol, write the name, write the period, so it will help you to know this. So children, next class I will be talking to you the variable valency, the valency exhibited by the transition elements, the D block elements of the periodic table. They are called as B subgroup elements. Thank you so much for listening so nicely. Just you think about it. I will be next class, go through the notes I have given you, go through the picture I have written, open your periodic table. Next class, where I will talk to you the valency of exhibited by the D block elements or B subgroup elements of the periodic table. Thank you very much.